Who of you did ever do an estimation that was wrong? Hopefully all of you, otherwise you just don't estimate at all. Yeah, I work at a software agency and we need to estimate a lot of our stuff to our customers, and then they also expect it to be more or less accurate. And this sometimes causes trouble. Some customers are easy, some customers are more difficult to communicate. And yeah, Ines will tell us a lot about her approach to this thing called estimations. So warm welcome to Ines. Thank you.
Hello, my name is Ines, as we've established. I'm a software developer from Slovenia, and today I'd like to talk to you about software estimation. So I've been writing code for almost 20 years now, and that means that for almost 2 decades, people have been asking me this one question: how long will it take? And at the beginning, in like the first decade, I was like, yeah, I'm gonna give you a real number. I'm gonna figure out a true estimate for this project. But it doesn't matter whatever thing I tried, it always felt like basically what I'm doing is just guessing. And I know that it's not the consensus among all developers. I know there's a lot of developers out there who are like, I am very good at estimating. I can really do this thing. But there is actually research on this topic. Scientists have went out into the world and they measured developers, how good we are at estimating, and scientists have figured out that we are horrendous at estimating. So I thought, let's travel the world and let's tell everybody about how not that good we are. Okay, so here's the initial truth. You will never be able to accurately estimate the time and effort it will take you to build a piece of software, for as long as you keep doing new things. It is just a fact of life that estimates are based on past experiences. And new projects, by definition, are things you haven't done before. If I came up to you and told you, can you make me a vase like this one? It doesn't have to be complicated, just like this, you see? But you have never made a vase before. So your only true answer can be, I have no idea how long that will take. Okay. What if I give you a spec, 20 pages, very precise, exactly what you need to do, and I will give you a team of 3 people. How long will it take you? And remember, it doesn't have to be accurate, just like give me a number. The thing is, none of the things I listed are helpful. Not the spec, not the resources you are provided. The truth is, we still have no idea. So the truth is that estimating, you can only estimate projects that you're very familiar with. And only if they're done by a team that you're also very familiar with. And obviously also if the organization where this is happening and the circumstances are also something that you're very familiar with. And most of the times, we are not very familiar with any one of these things, let alone all of them. It has been known since the 70s that developers tend to give over-optimistic estimations. And nothing has really changed since then. And one of the reasons that nothing has changed is because of our naive way, how we often estimate. What we do is we take a big project, we split it up into a lot of small tasks, and then we estimate each one of these small tasks. And then we make that huge mistake where we just sum up the number. But the thing is, it is nearly impossible to come up with a complete list of every possible task that needs to be done for this project to actually hit users in production. We especially tend to forget the unknown unknowns. So those are problems that we don't know we will be having. We will only see them when we're staring them down somewhere deep down in some detail. And also there's a big difference between, the core of this feature is working on my machine, and this feature is actually deployed in production and users are using it. Another reason that developers tend to give really bad estimates is because we oftentimes or almost never, almost never track the actual time that went into tasks. So we like to say, oh, yeah, this will take this much and this will take that much. But then we don't go back and measure how long it actually took. And if we don't measure, then we cannot compare. And if we cannot compare, we cannot get better at it, right? It's like going to a tournament, archery tournament, shooting all your arrows, not looking at the target. You just know that at the end, you were on place 105. You don't know exactly why. And that is no way to get better at this sport, right? So a while back, there was a team of researchers that went into various organizations and they did some experiments. And I find this experiment particularly interesting. It's about, and it goes like this. Very complicated, I'll try to explain it. So they went into this one organization and they found 20 software professionals. So this is not 20 developers, this is 20 people who build software. And they put them into 5 teams. Each team had 1 developer, 1 project manager, 1 designer, and 1 customers relations person, so somebody who's dealing with customers. So out of these 4, the 2 of them, the developer and the project manager, are believed to have the most know-how of how to actually deliver the project. Whereas the other 2 are focused on people, either on users or the customer. And then they chose an old project of this company. And this project had an original estimate, and that was 1,240 hours. And this project was they also measured time on this project, so they knew that it was completed by 2,400 hours. So that we can already see is 100 hours over the time limit, right? And then they asked the original people on the project, what went wrong, right? Like, was it something unexpected? Did the customer change their mind a lot? Like, what went wrong? But they were assured that nothing really went wrong. This is just a very typical project for our organization. We just estimated it really poorly. And then they asked these 20 professionals that were participating in the study to estimate this project again, first by themselves, and then in the team that they were assigned to. And the numbers that you see here below are the results of what the team said the estimates were. And as you can see, they were all very optimistic up to the last one. The biggest one, that one's actually close to the actual number of hours. However, 2,250 is still 150 hours short. And percentage-wise, that's not a lot, but this is almost 1 full month of one person's time that they got wrong. And this was a very typical project, not something they never worked on before. Now, the first task was to estimate the project by themselves, right? And these are the average results by a group of people. So this is not all the results, because the slide is somewhat small to show you all the results. But developers, on average, believe that this project can be done in 660 hours. And as we can see, that's not even 1/3 of the way to the actual number of hours that will be spent on this project if we do it again. But, it was in the past, so. And then project managers were slightly better. And then designers were even better. And engagement managers, so that's customer relations people, were even better. So if you sometimes feel like you should multiply a number by 2 or 3, yes, you should. Just remember, developers on average were less than 30% there. So yes, just multiply. And if you ever feel like saying, how can this simple thing take so long? Just remember the first line. It feels as if it can be done in 600 hours, but it will actually take 4 times as long. One of the more interesting observations was that people with non-technical knowledge, non-technical background, came up with better estimates. Basically, the technical knowledge we as developers have compels us to underestimate the effort. We are really good at coding, and so if you ask me, can you create me this and this logic? I'm like, yeah, I can see it. There's a function, there's the call, there's the input, the output. I can see it. It's all already working together in my head. And we forget of all the other things that also need to be done for this solution to actually get to the customers. It was basically the people who talk to customers who have to go out and say, oh, the thing that we said that will be done by last month, it will take 2 months more. So it makes sense that they are the ones who gave the higher numbers, because maybe they also multiply by 2 whatever number you give them. And the same pattern was observed in other studies that were not touching software at all. When we're thinking about risk, there's a so-called inside and an outside view on risk and estimation by comparison. An inside view is when you concentrate on the details of the project, on the plan. You see the obstacles and you make a plan of how you're going to overcome the obstacles. You're creating the steps of the project and you're focused on the future. And that tends to produce optimistic results. An outside view turns out to be better. This is the view where you focus on statistics, on the past, on similar projects that have been completed in the past. And how long did those take, and what were the problems with those projects? Research has simply shown that an outside view tends to produce more realistic estimates. And there's another powerful reason why developers give over-optimistic estimations that I specifically would like to emphasize, and that's the social component. If a developer is asked to give an estimate, there are 2 social constraints that guide her estimate. Firstly, the estimate cannot be huge, because that will basically stop the project before it even starts. And secondly, she cannot come up with a very wide estimate, so an estimate where the minimum and the maximum are very far apart. So either providing a wide estimate or an unexpectedly big one is both considered providing a useless estimate, which means you can neither say this very much seemingly simple thing will take 1 year to build, nor can you say, oh, this seemingly straightforward thing is going to take anywhere between a week and a year to build. Both of those things are whatever, nobody's listening to. And a similar thing has been seen in research. Here's another experiment. So they got 37 software professionals who had experience with project management into a room. And then they gave them 5 hypothetical tasks. So hypothetical, this didn't actually happen. And 2 hypothetical developers. Both developers would have estimated these tasks. One always gave a very narrow minimum and maximum, and one always gave a very wide minimum and maximum. And mathematically speaking, if you provide a wider interval, it means you will be right more often. And that is why developer 2's estimates were correct in 4 of these hypothetical tasks out of 5, whereas developer 1 was correct only 3 times out of 5. And then the participants were asked the following questions. As a project manager, would you prefer the estimates of developer 1 or developer 2? 35 out of 37 people, that's 95%, preferred developer 1, even though their estimates were objectively worse. And then there was another question. Do you believe developer 1 or developer 2 knew more about how to solve the task? 80% of them chose developer 1. Again, he was right only 3 times out of 5. And you would say, okay, but the other 20% chose developer 2. No, they didn't. Only 1 person chose developer 2. The other said, they don't have enough information. Only 1 person chose developer 2. We prefer to have exact numbers, even when it means that they are completely wrong. We want to have certainty, the feeling that somebody is in control, or at the very least, they should pretend they're in control. Self-confidence rules. We are definitely not rational beings, but more emotional. So to solve this problem of unreliable human estimations, some have turned to mathematics and to data science, thinking surely there's a formula out there, a natural connection between time and effort, and it's completely irrelevant of the organization or the team or the customer or whatever. Instead of asking a human, let's ask an algorithm. We have this notion that everything that is human is flawed and biased. And everything that's from a computer is not flawed and not biased at all. Even though study after study has shown that that is not true. We have absolutely no problem putting our own biases directly into the code. Still, we do want to transcend the human. We want to have like a simple, highly portable formula. We want it to be so that you can put in 5 to 10 parameters and then it spits out the exact number and you can use it here and tomorrow and forever and ever on every project from now until forever. And when we're building these mathematical models, we're often pretending to be searching for a law of nature, for a natural relationship. But it turns out that this never works. Again, research tells that the best mathematical models are those that are highly calibrated to the exact theme that they are measuring. So that means you need to have a stable team. No hiring, no firing, no changing up teams all the time. And you need to measure everything this team does. You need to split down their tasks into the smallest possible tasks, measure them, categorize them, so that you build this huge mountain of data that you can use to teach your mathematical model. And that basically means we're back to experiences. If you have done this task before and have measured it, then you know how long it will take you to do it again. So unfortunately, for every existing mathematical model, there are a few studies praising it and a bunch pointing out its shortcomings. And it turns out mathematical models are no better than human models. The problem appears to be, at least, that we just don't know what to have as input into these models. So we oftentimes use them in theory, and so we can put in stuff that will only be known after the project is done, like lines of code. Obviously, we don't know how many lines of code a project will produce before it is done. Or we use metrics that are extremely subjective, like number of function points that this will bring, or what's the t-shirt sizing of it. We're basically replacing one guess with another. And it feels like kicking the can down the road. We cannot figure out what the estimate for the project's deadline is, so we'll try to estimate the project's lines of code. But we don't know how to get that number, so we will try to figure out the function points for this project. But we don't really know how to get that number, so we're just going to analyze the text spec, and we're going to search for certain words. But we can't really trust those certain words, so we're going to first collect like a dictionary of synonyms that people can use so that those also count. You get my point. It's just replacing one guess with another. And the more I read about this, the more it felt like I'm reading about nutrition, like which food is good for us, which is healthy. Fish is really healthy, except for the mercury. Vegetables, really healthy, except for the pesticides. So there is no solution. Okay, so what can we actually do? First off, we need to understand the motivation behind it. Why are people asking, how long will it take you to build me this piece of software? It's because they don't have the resources to work on this one project from now and until forever. And this is an understandable concern. But if the goal is to minimize the resources, we can do that by just making the project simpler. No matter what you're building, we can make it faster if we cut corners. Let's make it less pretty, less error safe, less user-friendly. It's going to be faster. And here's the catch. People don't want the fast software or the simplest software. What they actually want is the best that they can get for their money. So the true question isn't how long will this take, it is what can you build me for this much money? Okay, so since it was never about time, but always about money, then let's flip the problem upside down. We will always be bad at estimating, because estimating is like predicting the future. That's just not something that we're good at. So let's embrace this limitation. People are actually very forgiving with delays as long as they're small delays. A delay on a software project of 2 days, that's understandable. Even a week, generally acceptable. So let's only estimate small projects. Problem solved. But how do we get to only small projects? Instead of diving deep into the whole project and measuring the total time and effort, let's split up the problem into several projects. Let's build the project iteratively. Let's first organize the requirements by priority. What are the core functionality, the things that absolutely have to exist, and then what's optional? And there is always something that's actually optional, no matter how much people pretend that everything's a requirement. And then let's first build the foundations and the core functionality. And then let's review. If we still have time and resources left, we can continue splitting up the optional into another core and optional and continuing with the core. And then if we still have resources left, We can continue and so on until eternity. This way, we promise that we have optimized the resources. We went down the priority list and always focused on the more important stuff. Okay, what about tasks that cannot be split down? It's like you either upgrade to a new Python version or you don't. You can't do that. The answer is the same. We still do it iteratively, but in a slightly different way. So the first step here needs to be an honest discussion with everybody involved about why this project might be important. Here's a list of all the things that we will gain by doing this project, and here's a list of all the risks. Because fact remains, we don't know how long this project will last. So we need to talk about the risks. And one of the things on the list of risks has to be that we will maybe start this project. And then after a while, we'll work on it for quite some time. And then we'll figure out it was a bad idea. And even if we have already spent 20 months working on this project, we should still stop it if we have come to the realization that it is a bad idea. And that's a conversation that needs to happen before the project starts, not in the middle or after. So, but if it does work, if you do decide, yes, this is worth the risk, let's do it, we can still do it iteratively in a way that we give somebody just a few hours a day and a few hours a week in which they can start working on this. They can start researching, start figuring out what the bigger problems are, or start finding solutions for the bigger problems. And if that goes well, we give them more resources, more time, maybe even a whole team of people. We just increment the resources iteratively because we cannot do that to the features. At my current stage in life, I find that everybody who is participating in a project is much more happier if we do it in iterations. We don't have to decide everything from the get-go. We should first concentrate on the essential bits, things that can be done in a few days, a few weeks, a month at most. It is much less risky to wait for somebody to spend 2 weeks on a project and then review the results, review the results, and then to decide whether to continue, than it is to wait for months on end before any sort of review starts. And an amusing consequence of this approach is then the developer and also the product also first concentrate on the essential bits. Maybe the first goal is just a proof of concept, something ugly, but something that works. Or maybe the first goal is just research into the hard bits, the things where we are not sure if it can be done. Either way, everybody is kept in the loop of the progress, and being kept in the loop is what makes the risk lesser. So maybe it's time we stop estimating things left and right and start managing the project's risk and the customer's expectations. Just talk to people, build relationships. The important thing is to make them trust you that you will not be lazy on this project. And also make them take responsibility for the estimates, for the time that's needed. Because at the end of the day, you are just building the project. You did not decide on the requirements. That is something they've decided on. And be transparent. Explain why something will take such and such long time. And give them options. We can go down this road and it has these risks and consequences, or we can go down this road and it has these advantages. I think this is better, but what do you think? Estimations can be built together because the requirements can be built together. And then they become common responsibilities. Okay, that's my take on estimations. You can find all the research that I've quoted in the link, in the QR code that's linked. And now it's time for questions.
There's a question back in the corner.
Oh.
Thank you. My question is about pricing models. So I work with clients, and negotiating the time it takes also involves negotiating the cost. And do you have any suggestions for this collaborative approach to arriving at a number for money? Because arriving at a number for time is hard enough, but then when it involves people negotiating for money, they're even more sensitive.
I think that time and money should be separate. I feel like, obviously, obviously, if it takes you an hour to build something, it should cost less than if it takes you a year. But if it takes you a month to build something, but that is very valuable to the customer, that has a very different price than if it also takes you a month, but it has very little value to them. This idea that you will give them an exact number of hours and that translates into the exact number of money that they have to send you are you working for them or are you a separate company, right? And also, forgot what I wanted to say. Yeah.
Yeah. So did it answer your question? Yeah. All right. Are there more questions in the room? There's one right over there.
Thank you so much. I would like to ask you about the importance, how do you think communication is also an important factor of estimation based on also the value that just Jerome mentioned? Thank you.
Yes, that's what I wanted to say before. Communication, right? So basically, you are the expert. You are not without opinions or without value. You are the expert. You can say this has to be done or this doesn't have to be done. It has these consequences. And you can, the thing is that if you go to the doctors, you also ask them, okay, so what are my options, right? And what are the consequences? They don't promise you they will find you a solution, but they offer you options. And you can say, as an expert, I have seen this, and this is where I'm pretty certain about, and this is where I'm not certain about. And being honest and just like building this relationship, that is honestly everything that you can do. Nobody can force you, if it's impossible to estimate, then nobody can force you to estimate if it's impossible, right?
All right. Are there more questions? I see 2 hands here. Let's do the back one first.
For the talk. It's more of a comment. Perhaps I agree totally that we should not do all this estimating of tasks, but I think that for projects which are obviously very large, like replacing some kind of legacy system or something like that, it's very useful to do kind of ballpark estimation at the very start, very simple, based on simple calculations, so that you can basically do the go, no-go decision. That's what I find most useful. What do you think about that?
Yeah, of course. If you have done this very similar project before, then you have a feeling of how big it will be, right? And then you can ballpark it, and you can say, oh, usually when we upgraded Python from 3 to 3.5 or whatever, it took this much time, and so you can ballpark it. But the problem is usually that we get asked to estimate projects that are completely different than anything that we've done before. And we cannot estimate that at all, not even ballpark it. We can just say it will take somewhere between a week and a year, which is not good enough for them. But it is the truth. So, if you have projects that are very similar, then you can always estimate them. If you put the time into measuring how much it took you in the past to do something, then this becomes a much easier task, but you have to be willing to put in that work.
Was a question up there? Can you raise your hand again? Yeah. In the front.
Thank you.
Thank you for your talk. And to add a comment to the pricing model, there are some companies who just sell sprints, like sprint, and then they try to add the most amount of value in that given time. And now the question to you is, how does this incremental and iterative approach compare in your experience to frameworks like Scrum or agile approaches of working?
I think the problem with agile is that agile was just a mentality. It was just about let's be flexible. And then this infrastructure was built on top of it. Oh, for doing that, you need this and this and this, and you need a master, and you need to pay them, and you need this organization, blah, blah, blah. And that means also that every organization is doing it slightly differently. So at its core, agile is completely this. But the question is anybody actually doing agile, or are they just doing something agile similar to agile, something that somebody sold them that it is agile. I feel like what's the core of my idea, my presentation, and agile is just be flexible and communicate. Like, if this has to be done, then let's do it. And if it's optional, then let's think about under which circumstances we're willing to do it. Just flexibility.
All right. I think we have time for one more question. Is there still a question in the room? Over there?
Great talk, first of all, thank you. I'm wondering if you've ever seen a project where people put in the entirety of the effort you described to accurately measure tasks.
Obviously not. I think that I described that in such painful way because I don't think anybody would ever actually do that. But if you want a good mathematical model, that is what you need to do. And so let's be honest, we're not going to do it. So what's the point of estimating too correctly?
All right. So thanks again for your talk and your time for answering the questions.